In this video, I want to demonstrate how to conduct panel unitary test in a app. So these are the panel unitary tests we'll be considering. So we're considering 5 first generation panel unitary tests and also 1 second generation panel unitary test. So here are the first generation panel unitary tests we're considering. We're considering LSC panel unitary test, IPS test, module test, Fisher type test, and Hadley test. For second generation test, we're considering CIPS parameter test. So now let's go. So I told you that wherever you find yourself in how, the first thing you do is to set your working directory. Make sure that you are in the right folder where you have your data set. So let me check if I'm already in right folder. If I'm not there, we'll try to set to reset that. So now to set the working directory, I go to session, then set working directory, choose directory. So here I can see, so my folder is panel econometric, so I'm in the right folder. So I just click on open. So then the next thing is to import my data set. To import my data set, I'm going to use the code read.csv. Then I put the name of data set.csv. So if I run the code in line 14, that will help me to import my data set. So you can see I've imported my data set. You can see from here that has been imported. So to view that, I can actually, to view my data set, I can run the code, the line of code in line 15. So if I run it, so it will bring my data set. You can see this here is my data set. Okay. So these are the variables we'll be using: investment, value, and capital stock. Then let's go back to the script. So for us to, before we can actually conduct panel unitary test or do any panel modeling, so we need a package called PLM. So I'm loading that package now using this code and this function library. And so we put the name of the package in bracket. So if I run this, it will help me to load the package called PLM. That will allow me to use function that will help me to conduct panel unitary test. So let me load that. So the package has been loaded. You can see from the console here. So since it does not return error, so that means so sorry about that. Yes. So you can see now. The next thing to do is to set my data set as panel. So I want to set my data set as panel. So I want to store it with the name p.groundfield. The original name of data set is groundfield, but I want to set as my panel and store that information as p.groundfield. So here is the function, okay, to set my data as panel. So I have p data.frame. So I write the name of the data set, the index, or C bracket, the cross section. Here the name of the cross section frames. You can see from data set frame cross section, and we have year. And so comma, then we also put year in inverted comma. So if I run this code in line 21, it will help me to set my uh, data set as panel data. So you can see I've been able to execute that. You can see it does not return any error. If you look at the environment here, they are also it also show that is the data set has been set as panel because no error is returned here. Now we are starting with the first generation test. Okay, I'll just run some of the tests here, so you can do the rest on your own. So we want to start with LSC test. Okay, so we'll be using one of the variables, okay, that is investment. So we'll be using investment. So we'll be using investment. So you make sure you study the name of the variable. That's invest. That's INV. So it's not written in full. So you have to take note of that. So meaning that I have to change to from invest to INV. You. So now here is the function. Okay, so to read about this function, this is the function we'll be using to perform a panel unitary test. That is panel unitary test. You can see for test, that's PUR test. Okay, to read about the function, just come to package here, then you search for PLM, 。 . 。 . 。 . 。 . 。 . . . . . . . . . . . . . . . . . . . . . . . . 。 。 . . 。 . . 。 . 。 . 。 . 。 . . . 。 . . . 。 . 。 So here, if I click on PLM here, it will bring all the function inside this particular PLM package. Okay, so here now I will now look for this particular function that will help assist me to uh, conduct parameter test. So I'm going to PU. So here is the function. You can see unit to test for panel data. You can see if I click on this function, so it's going to give me information about this function. That is PUR test. That's panel utility test. You can see here is the structure of the function. You can see. So you can read about the function here. Okay. You can read about it at your convenient time. So now moving back to the script. So I have the first argument in this function is the name of the uh, data is the name of the variable. Okay. But because you can see here, you have to be very careful. It's because I want to log this variable. That is why I put log first. Like you can see, I put log because originally these variables are not logged, but I want to log the variable I want to use. So I put log before I open a bracket. I put the name of data set already in panel format. You can see because this is p dot graphic. That's what I used as the name for panel setting. I put dollar sign. The dollar sign is used to extract the variable inv from these here in this is this data set. So there are many variables there. Okay, there are 6 variables here. So I put dollar inv. Okay, so inv telling our app that it should look for inv, that's investment from this data set. Okay, I close the bracket. Okay, then comma p max, that is p max, that is the maximum lag I want to include, usually 2. Then exo is telling me I set exo I set p max to 2, that is to use maximum lag of 2. And then exo whether tells me whether I want to I don't want to include intercept and trend. Here I'm saying I said I don't want to include intercept and trend, that is none. Then test, the name of the test I want to carry is LSC. So the option is that learning. So I'm going to put that in. Okay. So if I run this now, so it's going to help me to conduct that. You can see here, you can see this is the test. You can see the from the p-value here. This p-value is greater than 0.05. That is 5% level of significance. So it means that at level, okay, using specification with none. So uh, uh, this variable is not stationary. The investment is not stationary. So let me check if I include intercept, whether it's going to be stationary. So I'll just write the same line of code and change this exo to intercept. If I run this, I will check. So it's also not stationary. You can see it's also this p-value is also greater than 0.05. So let me include intercept and trend. If I include intercept and trend, let me see if it's going to be stationary. Okay, that is the third one. So intercept and trend. Okay, intercept and trends by including intercept and trend. So I can't intercept and trend. This variable investment is stationary. Okay, that is investment is stationary around trend. You can see it is stationary. So I conclude that investment is stationary. Okay, investment is stationary. Because this, you can see, don't be confused with this 3.0 is a minus 11, meaning that there is 11 zeros before 3. Okay, that is 0.000, like you have 10 zeros. Okay, 0 after point, that's the first zero is 0. The first 0, that is 1.10 before you have 3. So it is less than, this is less than 0.05. So this indicates that investment is stationary using LSC test. Okay. Okay. So since it is stationary, so we don't need to uh, carry out the test using first difference of the variable. So assuming it's not stationary, so the only thing is that I'm going to manipulate this code by just adding diff before log. You can see this diff is the function that will help me to difference this variable. It's going to help me to difference this variable. to first difference this variable before carrying out the test on it. Okay. So now let's move to uh, IPS test. IPS test. Okay. You can see the same format. Okay. But the only difference is that you can see here. Uh, you can see you have four tests. You can see test. You see, but you are going to change the name of the test from Lebanon to IPS. Okay. So it's missing here. So let me copy it and hide it here. Okay. So mind you, for IPS, okay, none inspection with none is not available. We only have inspection with intercept only and intercept and trend. Okay. So now let's try to conduct neutral test. Okay. So we have uh, an IPS, you can see. So we have intercept, but we are going to include intercept only first. Okay. At you can see on the log of free GDP level, that is without differential. Okay. So if I run this, you can see here, this is IPS test. This is greater than 0.05. Okay, it's greater than 0.05. So meaning that this variable is not stationary at at 5% level significant according to IPS. So let's include intercept and trend by running the line of code in 38. Let's see if it's going to be stationary. So if we include in trend, intercept and trend, so it shows that our variable is stationary. You can see as this is less than uh 0.05. Okay. So if so we don't need to do any further test by differencing. Any further test is saying that we don't need to use IPS again by differencing our variable. So assuming it's not stationary at first difference, we can also, I mean at level, we can also want to use the difference. Okay. So we can also carry out Madala wool test. You can see the same format, just read through it. You just need to change the name of the test. Okay. You just change the name of the test. So you go like that. Okay. We also have choice test. Choice test. You can see choice test. You have description there. Okay. Choice test has three variants of test. We have because it's an is an Fisher is a Fisher type test. So we have inverse normal test, we have logic test, and we have PM test. Okay, this PM test is mainly for large N when you have large N. Okay, so let me just run one of these. If I run this, then say it's not stationary. If I include the intercept only, let's say going stationary, it's not stationary. What of if I include intercept and trend? Let's see. So if I include intercept and trend, so it's now stationary. You can say according to choice test. Okay, so we stationary. Now let's look at the ADRI test. Mind you, the non-hypothesis for ID test is different from other tests. For other tests, the non-hypothesis is that the variable is not stationary. But for ADRI, the non-hypothesis is that the variable is stationary. The variable is stationary. That is for ID. Meaning that if we use ADRI, we are not expected to reject the non-hypothesis to conclude that the variable is stationary. So let's run ADRI test. So we have two specifications. Okay, mind the ADRI test allows us to also correct for heteroscedasticity. Okay, that is why we have 5A Roman figure, and we also have 5A Roman figure. We have 5A Roman figure 1, so that's repetition anyway. Okay, and 5A Roman figure 2. Okay, that's what you're supposed to have. Okay, so here, if I don't want to correct for heteroscedasticity, okay, I'll just say H. I will only have after changing the name of the test to ADRI, comma, and H comes equals to F, meaning that F means false. I don't want to correct for heteroscedasticity. So let me run this. If I run this test, so it tells me, so is there if I include in just intercept? Okay, without trend, the variable is not stationary because I reject the non-hypothesis. Mind I told you that for ADRI test, you shouldn't reject the non-hypothesis or to say the variable is stationary. Okay, okay, the variable is stationary. Okay, you can see the non-hypothesis here. See, at least one series has is unit test. But you can see the sorry, you can see the alternative hypothesis here. That says that at least one series has a unit root. The non-hypothesis is that no series has a unit root. So we are not expecting to reject non-hypothesis or to say there is stationarity. So let's include intercept and trend and see. And we include intercept and trend. It shows that the variable is stationary. So the result align with the result of other tests we have done before. Okay. So now let's move to the second generation test. Second generation test. So you can also read about the second generation test. We are going to use CIP test, okay, for that. So you can come here and it is available in the same package. CR, that's the PLM test. You can see CIP test. That's cross-sectionally augmented IPS test for use in panel mode. You can see, okay, this is it. This is the structure. You can see this is the structure. You can read about it. Okay. So now you have at level, you can see you have the name of the variable. You can see we select the variable, then type. We don't want to include intercept and trend in our specification. If I run that now, let's see, you can see this is not stationary. If I don't include intercept or trend, okay, intercept or trend. If I don't include it. So if I include only intercept, I will change type to drift to include intercept. Okay. So if I let's see, if I also include that it is not stationary. Okay, it's also not stationary. You can see because I can now reject the non I cannot reject non Let's see if we include trend and intercept. Let's see if the tool is going to change. Okay, you can see it's also not stationary. Okay, that is so it may be that the variable there is no consecutive dependence uh, among our cross-sectional units. Okay, it may be the reason. Why the only difference between first generation test and second generation test is that all the first generation tests assume uh, that there is no cross-sectional dependence. Okay, among the cross-sectional units. The cross-sectional units are not uh, dependent. Okay, why second generation test assume they are dependent. Okay, so let's check at first difference. The same test as first difference. Let's check as first difference. Okay, if I run a line of code in 91, if I run that, so if I run that as first difference, using Perseverance CIP test, so it shows that it is stationary. Let me, if I also include drift, if I include drift, okay, it's not stationary. If I include trend, it's not stationary. It's only if I don't include that. This is just for second generation test. Okay, thank you.